Okay, this is the stairs sample video. So I'm going to go to the sample problem. And it says that if Mr. Seward moves his 226-pound body up 11 stairs that are 9¼ inches tall in 6.25 seconds, how much work did he perform? How much horsepower did he use? So I'm going to show you my calculations for this and show you how I work through this. So first of all, we have the work formula right here. Remember, that is the force, which is weight times distance. And I'm going to show you the engineering formula sheet where that is. This is attached, by the way, to this Google Classroom post, and it's W equals force times distance. It's right there for us. Now, back to the problem. So how much work did he use? All right, here's the calculation. So number one, I used the force. So I had to find the force, which was 226 pounds. And then the second thing I need to do is calculate the distance. So there are 11 stairs and they are 9¼ inches tall. Now this is all got to be in feet. So I'm going to have to convert this quarter inch, 1/4, into a decimal. And I think we all know probably that a quarter of an inch is 0.25 of an inch. It's 1/4. So I'm going to take the 11 stairs and I'm going to multiply that times 9.25 inches, and that is going to give me 101.75 inches. Now, we have to convert inches to feet here. So, and the reason for that is because this answer has to be in pound feet, not in inch feet. So I'm going to take that 101.75 inches and I'm going to multiply that times 1 foot over 12 inches. The inches are going to cancel out. So once I take 101.75 and divide that by 12, I'm going to get 8.48 feet. So now I can calculate using the formula. So my W is going to be equal to 226 pounds times 8.48 feet. That's going to give me 1,916.48 foot-pounds. Sorry. Now I'm going to take that value and I'm going to go down to my power formula. And again, I'm going to go back to my formula sheet. Oops, there he is. I'll show you where that is. That is right here. So P is equal to W divided by T, where T is time. Okay, so back to our sheet. So P equals W over T, and so P is equal to the 1,916.48 foot-pounds divided by 6.25 seconds. When I divide 6.25 into that, I'm going to end up with, I rounded, 307 foot-pounds per second. So that's our fourth step. Now, our fifth step is to convert horsepower, or I'm sorry, we're going to calculate the horsepower, and we're going to take our foot-pounds and we're going to divide that by our 500, our constant value of 550 foot-pounds. So back to our formula sheet and see if I can find this nice and quick. Yeah, here it is, right here. So on the sheet that says 6 conversions right here, 1 horsepower is equal to 550 foot-pounds per second. So you can lift an item in 1 second that weighs 550 pounds. You're going to generate 1 horsepower with that. So that's our formula sheet for that. So back to this. So now I'm going to take my 1 horsepower equals 550 foot-pounds per second. I'm going to write down my 307 foot-pounds per second up here. Put that all over 1. I'm going to multiply this times the 1 horsepower divided by 550 foot-pounds. The foot-pounds per second and foot-pounds per second over here cancel out. I'm going to end up with 307 HP divided by 550. That's going to give me 0.56 HP or horsepower. So let's see if I think I'll have to maybe move that down. So this is the example or the calculation of how to do this particular problem. The only way that this differs from any of the others is we had a fraction here that we had to convert to a decimal.